living through a golden age of science that's paying off with one discovery after another.
This is how we control all the components of the accelerator here.
Florida State University uses this accelerator to study how stars form the building blocks of matter. And along the way, their physicists made strides in treating cancer.
And we suddenly realized, wait, this could be useful for this.
Meanwhile, researchers at the University of Central Florida turbocharge our natural cells as part of an effort to devour cancer from within.
You could see him just swarming the tumors and tearing it into pieces.
And this UCF professor developed a new kind of paint that never fades, repels heat, and could substantially reduce our power bills.
It's extremely lightweight. It looks like a water. You can actually feel it. It's like a water.
But we'll start with the quantum leap in developing safe and stable hypersonic travel. From one side of the world to the other in a matter of minutes. All in this edition of Breakthroughs in Science.
Well, NASA developed the X-59 to break the speed barrier without emitting the deafening supersonic boom on people below. And right now, commercial airlines are producing a new generation of supersonic jets to cut passenger flight times in half. But while that's all drawing a great deal of excitement, as it should, these students at the University of Central Florida have already taken a much greater leap. In the future, how long will it take to get from Tampa to Los Angeles?
So when you take off from an airport, once you're up in the air at altitude, it's sub 10 minutes, you're already in LA.
10 minutes by air from Tampa to California.
Yes.
Now, they've not yet built such a jet, but they did figure out how to stabilize a hypersonic engine in this lab. That's hypersonic as opposed to supersonic. NASA's X-59 supersonic aircraft is designed to fly 925 miles per hour. UCF's hypersonic design could lead up to air travel 14 times faster, up to 13,000 miles per hour.
The first reaction was actually denial. So from not believing it's actually real.
Now, for context, we've powered engines through internal combustion for more than 200 years.
When you have like a fuel injector on a car, it sprays mist into your combustor.
The fuel mist burns, which releases energy, which drives motion. And so we currently ride or fly on comparatively slow, controlled reactions like a burning candle flame. But with hypersonic engines, instead of a slow burn, they set off a chain of powerful explosions, which drives much more motion with much less fuel.
That controlled explosion is highly efficient in releasing that energy compared to your typical candle flame, which you fly on today. That is not an efficient process.
But while hypersonic engines are far more powerful and efficient, they can also be unstable.
The problem with the detonation process is that it's unsteady and very hard to control.
And that's where Dr. Karim Ahmed and his students broke new ground. They developed and tested the world's first hypersonic engine that can stabilize the detonation. So what were you thinking? Holy smoke, we did it!
Yes, we were able to stabilize it repeatably. It was exciting that now we've got the world first stabilized oblique detonation wave.
Here's their first experiment that drew attention around the world. It's basically a tube split into 3 parts. The first part ignites an injection of hydrogen and oxygen, and the second part injects more hydrogen. And as the burst shoots into the third section, it hits this 30-degree ramp. And that ramp holds and stabilizes the shockwave reaction. So you get thrust from the explosion and a shockwave to keep the explosion going until they cut off the fuel. And this is how that burst of thrust looks in the lab. Rachel Heidevick is a doctoral student from Tampa. Here's how she explains what we just witnessed to her family and friends.
Most of the time I just say I study fire and how to make fire happen faster. And then if fire can happen faster, then we can get places faster.
This chart shows how they sustain the detonation wave for 3 seconds before they cut off the fuel. The next steps are to keep repeating the experiment and to keep expanding it.
Can we predict its behavior and achieve it every time reliably? Once you're at that phase, you're ready for that technology transition.
They've already built a second, much longer tube.
I've been spending every single day here at the lab since I started my PhD, designing this from the ground up.
They are not setting off any sonic booms and don't plan to, but it's still very loud and jars people who aren't used to it. 3, 2, 1. The sound you hear on television does not reflect how it sounds in person.
I am very used to it. We still regularly shock passersby.
With that kind of a shot, how does this whole tube not shoot back?
Lots of cinder blocks and a giant metal claw that holds it to the foundation.
While they're still testing the detonation wave engine, they've already conceived how it will look and work in flight. In concept, a more traditional aircraft will take off and carry the hypersonic craft into the air and then let it go. Then a rocket booster will accelerate it to supersonic speed, and then they'll fire up the hypersonic chamber. Shock waves will ignite the fuel, and that slope design, that 30-degree ramp built into the chamber, will stabilize the detonation wave, maintaining hypersonic speed until it's time to land from one continent to another in a matter of minutes. When will you be able to have commercial jets that can do this here on Earth?
Maybe by 2050, probably that technology would be realized.
And beyond that, it could shoot future astronauts into space and speed up travel to the moon, Mars, and who knows where.
Coming up, we'll explain how the Large Hadron Collider revealed an energy field that creates matter as we know it. And we'll take you to FSU's accelerator, where scientists are studying nuclear reactions while helping to develop new ways of treating cancer.
All around the world, scientists are using particle accelerators to solve the mysteries of existence. The best known example is CERN's Large Hadron Collider in Switzerland and France. It discovered the so-called God particle.
Well, I would like to add my congratulations to everybody involved in this tremendous achievement.
According to science, the tiniest particles form as ripples in cosmic energy fields. But we couldn't figure out how particles form mass if they're just ripples in an energy field. So a scientist named Peter Higgs figured there must be a force field that we hadn't yet discovered that physicists have likened to sort of a cosmic molasses. And as a particle or ripple moves through it, that's what causes the resistance to its movement that we call its mass. And then by speeding and smashing particles in the Large Hadron Collider, they jostled that cosmic molasses just enough to see it jiggle or bump on their charts to confirm that Peter Higgs was right, that there is what we now call a Higgs field and a particle called a Higgs boson, which gives other particles their mass.
For me, it's really an incredible thing that it's happened in my lifetime.
And now other incredible things are happening in another particle accelerator much closer to home. You'll find it at Florida State University in the Leroy Collins Research Lab. It's named after the governor who established FSU's nuclear physics department. Dr. Ingo Wiedenhofer is the Accelerator Lab's director.
And this is how we control all the components of the accelerator here.
They fire carbon ions that have a negative charge into this chamber and then shoot up to 9 million volts into a plate in the middle of the chamber.
And when the negative ions see that, they are accelerated towards it. They are attracted by it. Then, when they have reached the 9 million volts, we play a dirty trick on them.
And they strip off their electrons, switching the ion's charge, and that repels it from the high voltage plate in the middle that it had been attracted to, and then fires it toward the other side of the chamber.
Now I'll show you the second stage accelerator.
The second stage, which you kind of have to wiggle through this concrete wall to see, then shoots that hurtling carbon through super cold tanks of liquid helium and nitrogen. And this is where perfectly timed radio waves kick it forward over and over again.
We can get up to about 20% of the speed of light with this setup.
And from there, they can steer it through a network of pipes to whichever experiment they want to do with it on any given day.
And there's about $1 million worth of germanium crystals surrounding this thing to detect gamma rays.
They can track gamma rays, measure the nuclei's spin, and study the same nuclear reactions that take place inside of stars, some for only a fraction of a second.
Where we produce radioactive beams, we send it all the way through here, and then this is the detector.
And this is how they're using all of this to figure out how stars cook up the elements needed for life to exist, and to learn the complexities of a sun's cooking process, which could help us improve fusion energy reactors on Earth. Maybe one day help figure out other stuff we can't even mention yet because we don't yet know that it exists. And by accelerating these particles, the physicists at Florida State University are not just solving the mysteries of how everything came to be, they're also going to work on saving lives. Because as it turns out, this technology also has some extraordinary medical applications.
Things that nobody ever thought of when we started doing the research, and we suddenly realized, wait, this could be useful for this.
Like treating cancer. Their carbon beams can fry a malignant tumor while doing little damage to the healthy human tissue around it.
If you treat a tumor with carbon ions, traveling at 20–30% of the speed of light, you can actually tune the energy of the carbon ions not to deposit energy around the tumor, but only in the tumor.
They're now working on this as an alternative to radiation therapy that can harm surrounding tissue.
We'll be making better cancer treatments because of the experiments we're doing there.
And they're now collaborating with the Mayo Clinic. They're helping it build a dedicated accelerator in Jacksonville that'll be the first carbon beam therapy lab on the continent.
We cannot do therapy, but we can study the interactions of our beams with living cells.
To learn how to repair our bodies in the course of figuring out how we and everything else are made.
Coming up, the fight against cancer heats up as we head back to UCF. These black dots are killer cells tearing cancer to bits.
We all were just amazed. This was, like watching a best movie in your life.
We know what a feeding frenzy looks like in nature. Predators discover and then swarm their prey. And that's also what happens inside of our bodies when natural killer cells attack. Watch this microscopic predator in white as it senses its prey, the green-colored cell. And now watch this feeding frenzy take off. The white killer cells surround it and chew into it from all sides until it's gone. And this is a very good thing because the green cells are cancer, and these killer cells eat cancer.
And we quickly learned that in testing with natural killer cells, how potent these natural killer cells are.
Now, we have these coursing through all of our bodies, but now scientists at the University of Central Florida are extracting them from donors and modifying them in this lab to make them much stronger and more effective.
We started in a lab that really had no particular direction.
Oh, the lab director, Dr. Alicia Kopik, found direction through experiments and personal loss. She lost her mom to cancer.
She should have lived no longer than a year.
But she also watched her mom outlive expectations and fight that cancer for the better part of 10 years.
I think part of her success was her strong immune system.
So Dr. Kopik focused on ways to fight cancer by boosting immunity. Now, researchers had already been working on ways to boost natural killer cells that cancer patients already had inside of them. But Dr. Kopik said those treatments were toxic and she wanted to find a better way to do it.
So we saw there is really big hope, but we have to have a way to, rather than making them grow in patients, we need to find easy ways to do it in the laboratory, to make large amounts of these cells to be given safely without any side effects.
And that led to this. Researchers collect killer cells from donors and then keep them in a red liquid that feeds the cells. And as the cells multiply, the liquid turns a cloudy orange, and that's how you know it's teeming with those natural killer cells. They put them in a bioreactor to stimulate them, and they mix in nanoparticles that stimulate two specific proteins. In layman's terms, they turbocharge them, and then put them in a petri dish with cancer cells and watch them feast.
The real moment was when we saw the videos of the NK cells actually killing tumors.
Here's the video from the microscope in the lab experiment. The tumor is colored red. It's neuroblastoma, a cancer that targets children and infants. And the black specks are those turbocharged natural killer cells encircling it and devouring it.
You could see him just swarming the tumors and tearing it into pieces. We all were just amazed. This was, like watching a best movie in your life.
The success of these lab experiments led to human trials that are still underway. And if those trials show these modified killer cells are safe and effective in people, well, the pharmaceutical industry already has the means to mass produce them. So within the next 5 years, cancer patients across the nation could get injections of enhanced killer cells that could eat their cancer away. Do you have to be a blood relative to be a donor of killer cells?
No, you don't. These cells have natural mechanisms to be able to tell healthy cell from diseased cells. and therefore they don't touch healthy cells of the patients, and therefore we can take them from anybody.
If the trials succeed, they hope to start with leukemia patients and then expand it to patients with other forms of cancer, and from there, potentially down the road, as a preventative to wipe out minute levels of cancer before we can even detect it.
Coming up, discover the magic of plasmonic paint. It doesn't fade, it repels heat, and it could save us a fortune.
What color pigment do you see on this butterfly's wings? A lot of you may say, well, obviously it's blue, but it actually has no pigment because a lot of butterfly wings are transparent. They just have these layers of tiny scales that let part of the visible light spectrum through and then block out the rest. So when we perceive color on a majority of butterfly wings, we're just seeing the parts of the visible spectrum that bounce off of their translucent scales. And that gave this color-obsessed professor at the University of Central Florida a bright idea.
So since childhood, I was fascinated about color. So I myself grow coral at home, have my colorful cows at my home. So I always driven by this curiosity that is there any way we can create artificial color?
Dr. Debashis Chanda dreamed of recreating the magic of butterfly wings in a bottle. And after years of experiments, he did it.
It's extremely lightweight. It looks like a water. You can actually feel it. It's like a water.
Look closer and it appears to be teeming with glitter, with each brew containing different colors and concentrations. They're actually loaded with nanoparticles, with each batch made to absorb or reflect specific light waves like butterflies do. And this can change our world.
So if you paint a roof of a building like that, it keeps the inside of the building much cooler because it does not absorb in infrared radiation.
Here's a lab experiment that shows how it could significantly reduce our electric bills. Dr. Chanda's team painted the roof of one model house with plasmonic paint and the other with more conventional paint. They placed thermometers inside both of the models and put both under the same heat lamp. And look at this. The model with traditional roof paint shot up to 94 degrees compared to 87 for the one with plasmonic paint. And this plasmonic paint could reduce temperatures up to 30 degrees, depending on the circumstances. And over time, that alone could save a fortune in the cost of air conditioning.
The structural color actually reflects all the infrared radiation, so it keeps the surface much cooler.
This can also preserve energy in electric car batteries, extending their range. And since conventional paint is much heavier, switching to plasmonic paint would reduce the weight of cars and jets, which would make them even more efficient. For context, to paint a 747 jumbo jet, UCF estimates you'd need more than 1,000 pounds of traditional paint, while you'd only need around 3 pounds of plasmonic paint. And plasmonic paint never wears out.
So it does not fade. A structure-dependent color, in principle, is supposed to stay forever.
You could paint your roof one time and never have to paint it again.
Now, there will be some natural wear and tear because of the rain and hailstorm and all of those. But if you take all of those out, the color itself not supposed to bleach.
And it could reduce pollution in manufacturing because plasmonic paint does not use the heavy metals that we often find in more common types of paint.
Like to create a deep blue, we need cobalt, and to create deep red, they add cadmium.
Well, here's where Dr. Chanda and UCF make their patented paint particles. This is an electron beam evaporator. They put small amounts of aluminum or sand inside and then shoot electrons into it until it evaporates into a gas.
So that gas goes up in the chamber and it's collected by a sample holder that we introduce through the transfer lock.
And that's how they produce the nanoparticles that absorb or bounce certain light waves, and then they mix the particles into a binder liquid which disperses the particles in a pattern to reflect specific colors of light. Now, it took years to perfect the formula. The earlier versions changed color depending on what angle you looked at a painted surface.
It can go from completely washed out color to a more richer color, from bluish to completely whitish colors.
They solved that by making the particles spread in a random fashion. And now the next big challenge is to make and sell this paint to consumers. You won't find it in a paint or hardware store just yet because they don't yet have electron beam evaporators. Can I look in there? Would I see anything?
Yeah, please go ahead.
Well, building out the manufacturing process will take time and money, but Dr. Chanda says it will take off as people discover the potential of plasmonic paint. Well, special thanks now to UCF and FSU for taking us through their labs and offering time with their experts for this edition. And if you've missed any of our prior shows, you'll find them online and on our Fox Local app. Look for our Breakthroughs in Science program, stream away, and go behind the scenes.
So as Alex was just saying, we have pendulums and spring systems that are suspending everything inside of the tank. And all of those things have their own sort of resonance.
You'll see how the University of Florida is working with NASA to build a giant space antenna to expand our view of the universe.
And get the clearest picture yet of how the universe came to be the way it is.
And follow the search for dark matter and see how they're developing some incredible new technology along the way.
We have a receiver which is sensitive to yoctowatts. And if it was in the front end of your cell phone, and you took your cell phone to Mars and turned it on, you have 4 bars from a station on Earth. That's how sensitive it is.
We also break down the science of fusion energy plants and condensed matter physics, which changes how matter behaves, and the coming age of quantum computers. All in our recent shows. Again, get caught up on the Fox Local app as we prepare for the next round of Breakthroughs in Science. I'm Craig Patrick, and thank you for watching.